This video is part of the lecture for multivariable calculus, and we are going to solve some examples about cross product. So let's start. Example 1. What is I cross j? Okay, as you know, I is the unit vector along the x-axis. So let me graph x-axis, y-axis, and then z-axis. Always label the axis. And then this is I, this is the vector j in here. So now for finding I cross j, all I need to do is to write definition. Let me just move this one a little, and then I'm gonna use definition of the cross product I, j, and then k. 1, 0, 0 is the components of I, 0, 1, 0 components of j. So I get I. I'm gonna remove the row and column containing I, so I'm gonna find the determinant of this matrix in here. So I get 0 minus 0, which is 0, and then negative j, I'm gonna get 1 times 0, which is 0, 0 times 0, and then plus k, and then I'm gonna find the determinant of this minor, which would be 1 minus 0, so 1. As you see, this is the vector k, and if you want to check your work, you need to put your right hand in the direction of I, curl your finger in the direction of j, and then your thumb shows direction for the cross product, which is k. That's correct. So the cross product would be the vector k. Example 2. The question is, are the vectors a 1 4 negative 7 and the vector b with the components 2, negative 1, and 4, and the vector c with the components 0, negative 9, and 18. Are they coplanar actually? By coplanar, I mean in the same plane. Are they in the same plane or not? How we can check? We have 3 vectors in here, and for them to be on the same plane, it means that they don't make a parallelepiped. So just assume that this is a, let me make a parallelepiped like this. Just assume that this is, for example, the vector a, this is the vector b, and this is the vector c. If they are not in the same plane, then they do make a parallelepiped, but if they are in the same plane, they don't. So we need to find the triple product of these 3. So a dot b cross c, this is the volume of the parallelepiped, and I'm gonna put 1 4 negative 7, 2 negative 1, and then 4 0 negative 9, and 18. And if you find this determinant, it would be 1 times negative 18 plus 36 minus 4 times 36, and then minus 7 times negative 18, and this is 0, and so the volume of the parallelepiped is 0, meaning that they are in the same plane. Great. That was example 2. Let's look at example 3. Find the vector this I plus j cross I minus j. Okay, so the question is this vector I plus j cross product with I minus j. I'm gonna distribute the cross product, so I'm gonna say I cross I and then minus I cross j. I'm gonna do it like that. I cross I minus I cross j, and now so I just did this distribution, and then I'm gonna write that. So I'm gonna make this one scalar, and then I'm gonna say plus j cross I and then minus j cross j. I know that I cross I would be 0. Why? It's just because the angle between a vector with itself, the angle is 0, meaning that the sign is 0 based on definition of the cross product. This is 0. So this is the 0 vector. This is also 0 vector. Now I cross j on the first example, we saw that this is k, so I have a negative k in here, and then j cross I put my fingers in the direction of j, curl in the direction of I, and then my thumb shows direction of the cross product k. So I get a negative k, and then I have another negative k in here. This negative is based on that, but this negative is for the cross product. So I get negative k minus k, so I get negative 2k. Very good. Let's work on example 4. Find the volume of parallelepiped with these A, which is I plus j, B is j plus k, and C is I plus j plus k. Okay, so the best strategy in here is to just calculate each one of them, right? So I'm gonna say A dot B cross C, it's equal to the determinant. I plus j would be 1, 1, 0. J plus k would be 0, 1, 0 plus 0, 0, 1. So that's why I get a 1 in here. And then this one is 1, 1, and then 1. So I'm gonna put 1, 1, 0, 0, 1, 1, and then 1, 1, 1. So we just need to calculate that. 1 times determinant here, which would be 1 minus 1, minus 1 times 0 times 1 minus 1 plus 0 times the determinant in here, which would be 0. So this is 0 as well. The answer is just 1. The volume of this parallelepiped is 1. Next example, which is example 5, find the area of parallelogram with vertices A, 1, 2, 3, B 1 3 6 and C 3 8 and then 6. Okay, so I have 3 points, A, B, and then C, and I want to find the area of the parallelogram that's made by these ones. How do I do that? Well, using the vectors, I can consider the vector AB, and I can consider the vector AB and AC, and then the area of the parallelogram would be the length of their cross product. So let me make AC cross product with AB. Okay, so AC is the coordinates of C minus the coordinates of A. So it would be 3 minus 1, 8 minus 2, and then 6 minus 3. And then cross product with AB, the coordinates of B minus the coordinates of A. So 1 minus 1, 3 minus 2, and 6 minus 3. So I get 2, 6, 3 cross product with a 0, 1, and then 3. And so the cross product would be I, J, and then K, 2, 6, 3, 0, 1, 3. And then if we do the cross product, we get 15I minus 6J plus 2K. I hope the answer is correct. And then the area would be the length of this vector, AC cross product with AB. That's the definition of the area of the parallelogram. All you need to do is to find the sides and then find the length of the cross product of the sides. So it would be square root of 15 squared plus 6 squared plus 4. Great.